Okay, so if you are on, awesome, welcome. And if you're not, then get on. I don't know. If you're not, then you're not hearing this. We're going to get started in a minute or two. If things cut out or anything like last time, let me know. Mr. G is under strict directions that there will be no Rocket League playing while we are live streaming tonight. So, let me know if it cuts out or anything. And we're going to get started in a minute. Let's see if we can get a couple people on. Again, we'll give everybody another minute and then we'll get started. We are talking all sorts of solving tonight. So we're going to go through these live streams based on the verbs that the Regents would use to ask you about them. And we're going to start with solving tonight because solving is sort of the foundational skill. If you can solve equations, everything else sort of builds off of that. So we're going to go through a different verb in each Regents review. Tonight is solve. And we'll get started in a second. Okay, so let's get started. So here's the deal with how these Regents reviews are going to work if this is your first one. Every Regents review, we're going to go through a different verb that the Regents would use to ask you. We're starting with solve tonight. And we're going to look at mixed questions based on that verb. So we can talk about the way to answer things, the way that things go from there, and some of the things the Regents will look for. So we're not just going to go topic by topic because I know that's what we're doing in our classes. So we're going to go much more sort of, critical thinking skill by critical thinking skill. Now, at any time, if you want to ask me a question, send them in the YouTube chat, send them on Remind. Make sure that you're doing that. This should supplement what you're doing in class. So if there's anything that you still have questions on, let me know. The other thing is, if the stream cuts out for any reason, please send me a remind right away. If you get kicked off, anything, because I've been having some issues with this lately, and we might need to figure out another way around that. So without further ado, let's get started. Shout out if you're there and say hi and ask any questions that you have at any time, okay? So when we talk about solve, we're really talking about equations. And for us in Algebra 2, these are sort of the main things that we've looked at. We've looked at radical equations, we've looked at quadratics, we look at systems, polynomials, rationals, exponentials, and logs. There are other things we can solve, but in general, these are the big ones. Now, we are going to need to be able to do these algebraically. We're also going to be able to do these using our calculator, and we'll talk more about that. I have an entire video about how to do anything possible on your calculator. Make sure that if you're looking for those calculator skills, you go look at that. That will be up probably later tonight. But I'm not going to go through the basic calculator skills here. I'll just talk about how I got there. Okay? So let's get started. So I'm going to start by looking at a radical equation. Notice we're seeing that word solve in there. So I want to solve for x. And the thing with a radical equation, there's two things to remember. Number one, you always want to get your radical by itself. And number two, you always want to make sure you're checking your solutions, because with any sort of radical equation and with any sort of rational equation, we can wind up with extraneous or extra solutions. So let's take a look at these. Let's see how this goes. So with a rational, again, remember we said that we want to start by getting our radical by itself. My radical is this part right here. So I'm going to subtract that 1 to the other side. So 8x minus 23 equals x minus 1. Once the radical is alone, then we can isolate the radical by squaring both sides. And from there, we can simplify. So the left side, 8x minus 23. The right side, I need to square this. Now remember, squaring means multiply it by itself. So you need to do x minus 1 times the quantity x minus 1. In other words, you're going to get x squared minus 2x plus 1. Now, what you have on your hands here is a quadratic equation. So what I want to do is get this equal to 0. Since this has a positive x squared, I'm going to move everything over to that side. It's going to just be easier for me to keep that x squared positive. So I will get 0 equals x squared minus 10x plus 24. And now I either can factor or do the quadratic formula. This is pretty easily factorable. So I want two numbers that add to be negative 10, multiply to be 24. That would be negative 6 and negative 4. And so I get x equals 6 and x equals 4, setting each of those equal to 0. Now, those are all well and good, but let's make sure that we check those. So plugging those back in, I need to show that the square root of 8 times 6 minus 23 plus 1 equals 6, which it does. And the square root of 8 times 4 minus 23 plus 1 equals 4, which it does. So I wind up with two solutions here. That won't always happen, but in this case, we do wind up with two solutions and both of them check. So that is your general approach with a radical equation. You are going to get the radical alone, use a reciprocal power on both sides, and then go from there with solving. Again, any questions? Remind, YouTube chat, send away. This is your live stream. All right, let's look at the next one. So these are kind of more calculator skills. And the reason that I know that is a couple things. Number one, it says rounded to the nearest hundredth. So if you guys see that, that's sort of shouting out to me nearest hundredth. Number two, look at these. We've got decimals and we've got absolute value. We've got all sorts of different things here that are a little bit wonky. So this tells me immediately that I need this to use my calculator for this. So to do that, I'm going to graph them. I'm going to put in y1, h of x. I'm going to put in y2, k of x. And I'm going to graph those. Now, one of them is an absolute value and it's negative, so it's going to look like this. The other is a cubic, and it's going to wind up looking like this. So what we're going to wind up with is 3 intersection points here. To find those intersections, remember we're going to do second, and then calc, which is the trace button, and then 5, which is intersect. And I'm going to look for those intersections. So go to where you think they are, hit enter. And so this is going to mean negative 1.30, negative 2.59, and 1.48. If you need help on those calculator skills of how to deal with this, where I'm looking to put in absolute values or find intersections, again, in your spare time, go to that calculator help video, and that will be something that's super, super, super helpful as we go. All right, questions? Send them along. Otherwise, this train keeps moving. Okay, next one. So, which value to the nearest tenth is not a solution where p equals q? If p is given and q is given. Now, you have a lot of different options here. You could actually plug in each one and see if it makes p equal q. That's a lot of work. Okay? You otherwise could set them equal. And again, notice it's not asking me for an algebraic solution. It's just saying to the nearest tenth. So I'm going to put in y1, p of x, and in y2, q of x. And I'm going to see where those are equal. And so doing that, again, you're going to get 3 intersections. And if you do second calc intersect, you're going to see that they hit each other at this, this, and that. This is the only place where those don't hit each other. So remember that you're looking at the x values and you're looking for where those intersect. Okay, let's look at another one. So what are the roots in simplest form of this equation? This is a quadratic equation. There are a lot of different ways that you can do this. I'm going to look at 2 because some are easier and some are a little bit more difficult. So if I look at this, when I see this, my very first instinct is to try to solve this using getting x by itself. So you might take this and subtract 98, and then you might divide both sides by 4, and then you might square root both sides. So doing that, I'm going to get that x equals plus or minus the square root of negative 98 over 4. Now that's all well and good, but we want to simplify that a little bit more. So let's think about how we could do this. So doing that, I could say, okay, x equals plus or minus. Now, I could do the square root of negative 98 over the square root of 4. That helps me a little bit. And let me just move all this over so I have a little bit more space. If I think about negative 98 and trying to simplify that, that is really I times the square root of 98, which is 49 times 2. So this is going to be plus or minus 7i radical 2 over the square root of 4, which is 2. So that would be my solution. Now, for a lot of people, that's not your favorite way to go about this. A lot of people might not think to go straight to try and get x alone, because often with a quadratic, we're not used to just getting x alone. The reason we could do that here was because there was no b value, right? The b value was 0. So let's say we wanted to do this a different way. We could use quadratic formula here. So a here is 4, b is 0, and c is 98. So I would have x equals 0 plus or minus the square root of 0 squared minus 4 times 98 all over 2 times 4. That is plus or minus square root of negative 1568 over 8. And now we're simplifying. So this would be equal to plus or minus this 28i radical 2, because 1568 is 784 times 2. And that's all over 8. And then I can simplify that. So that would be plus or minus 28 over 8 is 7 over 4. And again, we come out with that same solution. So 2 different ways to get to the same answer. With quadratics, remember there are multiple ways to solve it. You could complete the square, you could do all sorts of different things. But I think either going with trying to get x alone here or just using quadratic formula are your best bets. Okay, please feel free to send me questions at any time here. All right, the next one, solve the following system for x, y, and z. I have 3 of these. I guarantee that you're going to see one of these. Remember that your goal is to try to eliminate a variable, right? So I'm going to pick 2 equations and try to eliminate a variable in them. So let's see, what should I start with? Let's look at these first 2. Because I already see that 3y and negative 3y will eliminate each other. So I'm going to use those. So x plus 3y plus 5z equals 45. Remember, it might be helpful to put lines through your z's here. And then 6x minus 3y plus 2z equals negative 10. Now I'm not getting my z's and my 2's confused. I'm going to add those 2 equations together. So that gives me 7x, this is 0, plus 7z equals 35. Now let's pick 2 other equations. So now I did the first 2. Now I'm going to do the second and the third. So I'm going to do these 2. Those I'm going to do, and I always like to highlight this. I like to say, okay, 6x minus 3y plus 2z equals negative 10. Negative 2x plus 3y plus 8z equals 72. So combining those, I get 4x. Those cancel. Plus 10z, which is a great game if you've never played it, equals 62, right? And so I've got that equation. So when I think about doing these, remember we always divided them up into 3 columns. That's really my first column, right? So now what I'm going to do is take those 2 highlighted purple equations and do elimination with those. So I've got these, and I'm noticing that these don't just eliminate. So I'm going to need to do a little bit of work here. So I don't see that one is clearly a factor of the other. So I'm going to multiply the top by 4 and the bottom by negative 7. That will make them cancel. The x's cancel. So that would be 28x plus 28z equals 140. And negative 28x minus 70z equals negative 434. Combine those. Notice my x's cancel. So this gives me negative 42z equals negative 294. In other words, z comes out to be 7. So that's one of my solutions. Now we can go back and start to plug in. So I'm going to do my third column because I don't really have space for it over here. And so now I'm going to plug back in. So since I have z, I'm going to use one of these equations that only has two variables in it and plug back into that. So 4x plus 10 times 7 equals 62, which gives me 4x equals negative 8. So x equals negative 2. So now I have x, I have z, so now I just need y. I'm going to plug back in to any of the first equations, and I'm going to get that y equals 4. So remember that your solution should be written out as an ordered triple, negative 2, 4, and 7, x, y, and z. We will do some more of those, but again, that's just a good sort of refresher back into these. So if you have questions, if something doesn't make sense, you should be sending them to me because I'm just here alone talking to myself. No one's sending me any questions. So this would be your moment. If you have questions, please ask them. All right. Next one, we have another radical equation. So let's look at this baby. Radical equation. The radicals alone. Oh my goodness, it already is. That's great. I'm going to square both sides. And this is quadratic. So if it's quadratic, that means that I want to get it equal to 0. Get it equal to 0. So I'm going to leave my x squared as positive. So I will have x squared plus x minus 56 equals 0. That's pretty easily factorable. So x plus 8, x minus 7 equals 0. So I get x equals negative 8 and x equals 7. Now remember, you always need to be checking. Did I have any extraneous solutions? So plug back into the original. So if I do this, 56 minus negative 8, which is plus 8, does that equal negative 8? It does not. You cannot take a square root of 64 and get out negative 8. It's not the principal square root. So that's why I'm rejecting this. But if I plug in the square root of 56 minus 7, do I get out 7? Yes, that's true. So my only answer here is 7. All right, let's do another quadratic, and let's look at this one and think about what method we would use to approach this. Why is my camera not on? Because I just got out of the shower, and my hair is in a top knot, and I didn't feel like looking presentable. Harper says hi. She is hounding Mr. G for dinner right now. Okay, so let's look at this. This is quadratic. So I am going to add 5 over, so it equals 0. Now you could also complete the square on this. That would work, but we're going to start with this. So seeing this, can I think of any numbers that add to be 2, multiply to be 5? I cannot, because that doesn't exist over the integers. So I'm going to use quadratic formula. So x equals, and let's see what we've got. Negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 5 all over 2 times 1, which gives me negative 2 plus or minus the square root of negative 16 all over 2. And now let's simplify. So that gives me negative 2 plus or minus the square root of 16 is 4. Because it's a negative, you'd need an I all over 2. And we're going to divide each of these, Mrs. Blakely's little I Heart Math trick, to be negative 1 plus or minus 2i. That would be in a plus bi form, right? And that's my two solutions. Now, let's say you wanted to do this by completing the square. Maybe you're feeling adventurous, right? So to do completing the square, I'm going to leave a blank there. And I'm going to leave my negative 5 where it is because it doesn't have an x. So it's going to stay where it is. So now let's complete this square. So take the b term, take half of that, square it, and I'm going to add that here. Whatever I add to one side, I also add to the other. So this will give me x plus 1 squared. Remember, you can always take this variable and that number. And on the right side, I get negative 4. Now I've got these squares, so I can square root both sides. So I get x plus 1 equals plus or minus 2i. And lo and behold, x equals negative 1 plus or minus 2i. If you know how to complete the square, I actually think that's often easier. But if you don't, then that can be trickier. Okay, again, send questions. Me just talking to myself over here. All right, next one. I'm going to skip 8 because I feel like you guys are pretty good at these, and just for the sake of time, I'm going to skip it. If you want to go back to that, we can, but I would like to look at 9. So determine the values that satisfy the given equation. Remember that this is really just the idea of solving, right? It's really just solving. That's all I'm doing. So I'm going to use the fact that these both equal y. So this equals y and this equals y, right? And through the transitive property, which I know you remember from Geo, then you can set those equal to each other. It's using substitution also. So negative 2x plus 1 would equal negative 2x squared plus 3x plus 1. Now, I know that I can already hear somebody asking, Mrs. G, before we just put them in our calculator, why can't we do that now? Because of this big word right here. If it says algebraically and you just put it in your calculator, you are not getting credit for that. Make sure it goes in your calculator. Or I'm sorry, that you do it algebraically. Okay, so I've set them equal. I see this is quadratic because I have an exponent there. So let's go from there. Let's get these all to one side and let's get my leading coefficient to be positive. So I'm going to add 2x squared, subtract 3x, and subtract 1. Add 2x squared minus 3x minus 1. And this is going to give me 2x squared minus 5x, 0 equals 0. Now, often people will look at this and panic, sheer panic, because you don't think you can factor this. My friend, what is the first move you always make when you factor? It should be to look for a greatest common factor. So that's what I'm going to do here. I see that they both have an x in common. I'm going to take that out and then set each part equal to 0. So x equals 2 or x equals 5 over 2. Now, that is the values of x. It did not say the coordinate points or anything like that. Those are the values of x. And we'll look at ones later where we have to find coordinate points. Okay, let's look at the next one. Find the zeros for this algebraically. Again, it doesn't say the word solve, but it's asking you to solve. So algebraically, think you must do algebra. And what jumps out at me right away is that I feel like I need to factor. Anytime you have 4 terms, the first thing I would do is look for a GCF. And the next thing I would do is go to grouping. So when I look at these, I see that they all have an x. So I could at least take that out. And that would leave me x cubed minus 4x squared minus 9x plus 36 equals 0. Now, I still have 4 terms in here. So I'm going to factor by grouping. I'm going to group the first 2, group the second 2. And I'm not going to forget about my x. He's just going to hang out front. So GCF of these first 2 is x squared, leaving me x minus 4. GCF of the second 2 is negative 9, leaving me x minus 4. Hey, that's nice. And so this is really x times x squared minus 9 times x minus 4. Now you could solve it there, but let's factor it completely because we're good at that. X squared minus 9 is actually a difference of squares. So this would be factored completely. And then set each part equal to 0. So x equals 0, 3, negative 3, and 4. Notice I did set that equal to 0. It doesn't just go away. And the other thing is, remember, we had x to the 4th, so that means you should have 4 solutions here, right? They might not all be real solutions, but you should have 4 solutions. Okay. Rationals. Let's look at this baby. What is the solution set of this? Now, I know this is a multiple choice. I know you could just plug this in your calculator. I get that. I'm cool. But we also need to be able to do these algebraically because they can turn up on our free response. So let's look at this one. To solve these, you want to multiply through by your common denominator. Now here, that's over 1. And so I'm going to look at my denominators. The first one here is the factor x plus 7. Remember, sometimes it's helpful to put those in parentheses. Here, it's just x. Now, I notice those do not have common factors. The first one is x plus 7. And the second one is just x. And the third one's just 1. You can put that in there, but 1 times anything doesn't change it. So this is going to be my LCD. So I'm going to multiply that through to each one, and I'll show you what I mean. So on this first one, if I multiply it to this, it's going to be 3x plus 25 times x plus 7 times x, all over x plus 7, right? So I'm not doing any shortcuts here. I am multiplying through to each one. If you're good at this, you can kind of do some of this in your head, but if this is still something you struggle with, then you should be multiplying it out. Now multiply it to this one. This would be 3 times x plus 7. Remember, it's multiplication. It's commutative. Order doesn't matter. Plus 5 times x plus 7 all over 1. And here's the fun part. Now you can cancel because we've got these fractions. So the x plus 7's cancel, the x's cancel, and nothing cancels on the third. So here what you're left with is 3x plus 25 times x, which is 3x squared plus 25x. Here you're left with 3 times x plus 7, 3x plus 21. Here you're left with 5x times x plus 7, 5x squared plus 35x. Now this is quadratic, so I'm going to set it equal to 0. I'm going to move everything to the right side so that my x squared stays positive. 2x squared plus 13x plus 21. Now you could do quadratic formula, you could factor here. Let's factor because we love to factor, it's our favorite. So there's no GCF, so I'm going to multiply 2 times 21, that's 42. And I need factors of 42 that add to be 13. Well, the biggest factors of 42 that jump out at me are 6 and 7, and those do add to be 13. So 2x squared plus 6x plus 7x plus 21. Take out a 2x, that leaves me with x plus 3. Take out a 7, that leaves me with x plus 3. Oh my golly, I got it. 2x plus 7, x plus 3. And really, these are all still 0 equals. Set each of those equal to 0, so x should be negative 7 over 2, and x should be negative 3. Now, we need to check that neither of those are extraneous, so what we're going to do is check by plugging it back in. Or remember, the other thing you can do is think about your excluded values here. X cannot be negative 7 and x cannot be 0 because those are what make your denominator equal 0. As long as it's not those, these are cool. So your answer is D. All right, we've got about 3 more, maybe 4. We'll see how we're feeling. Let's look at this one, solve this system. So notice with this one, I can't just get the y alone, right? I can't just say, ooh, let's get y alone, and we're done. I'm going to have to use substitution here. So I'm going to pick whichever one's simpler, which is this one. It's much easier to get y alone there. So here, I'm going to subtract 2x over and divide both sides by 2. You could do this with y or with x also. It doesn't matter. And this is what I'm going to use to substitute in. So wherever I see a y, I'm going to plug that in instead. So this is going to be x minus 3 squared plus y, which is 5 minus x, plus 2 squared. And now notice at least it's all in terms of one variable. So this gives me x minus 3 squared plus 7 minus x squared. And you need to multiply each of those out. So this one would be x squared minus 6x plus 9 plus 49 minus 14x plus x squared equals 16. Notice that it's quadratic, so I'm going to combine all my like terms. So I get 2x squared minus 20x plus 42 equals 0. And let's try to factor. So I'm going to factor out a 2. You could also divide both sides by 2, but I like to factor it so we don't get confused on when we can divide and when we can factor. And then I'm going to get x minus 7, x minus 3. Now remember, we're setting each factor equal to 0. 2 will never equal 0, so it will not give me a solution. So here I get x equals 7 and x equals 3. Now that is just the x values. I want the solutions. So we still need to figure out the y values. So for 7, if we plug that back into here, if x is 7, then y is negative 2. And for 3, then y is positive 2. So my solutions would actually be the points 3, 2, and 7, negative 2. You should always write your answer as coordinate points. You should not just be leaving them willy-nilly because I don't always know what y goes with what x. It's important that you clarify that. Okay, now on this one, to solve, Jack multiplied both sides by the least common denominator, which statement is true. So if I look at this, I want to know where the extraneous roots solutions are. So I'm going to look at what kind of solutions would I have to reject, which would be whatever makes the bottom equal 0. Now, my factors in the bottom, this is really x times x minus 2. This one is just x minus 2. That one is just x. So notice we have some common factors. What would make x equal 0? Well, that would be 0, my friend. What would make 2 equal 0, or x minus 2 equal 0? That would be 2. So either of those would be extraneous solutions. All right, send more questions. I'm going to take like a 5-second break so I can take a sip of water, but you guys should be sending questions away. Nada? All right, let's get into some more fun equations because this is all about the solve. All right, so Diana puts $5,000 in an account with the interest rate compounded continuously. Immediately, PE to the RT, baby, right? Think per, okay? Now, find the approximate annual growth rate. So you're looking for R to the nearest hundredth for the account grown to 9,100 after 30 years. So I know that I have y equals PE to the RT. I am trying to solve for R. So let's start with what we know. We know that she starts with 5,000. We know E is just a constant. We want to find the rate, so we need the time, right? If we're looking for rate, we can only have one variable. So the time here is 30 years. And the y value is the final amount, which here is 9110. So I'm going to start by looking at what my exponential part is, which is just that. And remember, that needs to be alone. We always boxed it and then got it by itself. So divide both sides by 5,000, 1.822. And now once your exponential part's alone, you can convert. So logs are exponents, so it will always equal the exponent. Log base E, or you could say ln, of the answer. Now, from there, I'm going to need to divide both sides by 30. And so R to the nearest, what's it say, hundredth, is 0.02. Now, if it didn't say to do it algebraically, you could also put this one side in y1, put the other side in y2, and just see where they're equal. So remember, you have your calculator if you need it, if it doesn't specify algebraically. Okay, let's look at another one of these. So let's skip to 16. I really like 16 because it asks you to think about exponential growth and decay and logs in terms of variables. There's no numbers, right? So these are all positive numbers. Solve for t. So I know that a, that's a highlighter, a e to the b t equals c. So I'm going to do exactly what I always do, which is get the exponential part highlighted or in a box. And let's get that alone. So I'm going to start by dividing both sides by a. So e to the bt equals c over a. Now the exponential part's by itself. So I'm going to convert it to a log. So that would give me, logs are exponents, so b times t equals log base e, or you could say ln, both are correct, of c over a. And then to get t alone, divide both sides by b. So t is ln c over a all over b. Or you could have log base e also. Again, nothing crazy. Just do you know how to manipulate the variables? All right, let's do one more with a log, make sure we're okay on these, and then we'll go from there. So a substance has a mass of 140 grams at 3 p.m. and 100 grams, I can't read tonight, at 8 p.m. The equation 100 equals 140 times 1/2 to the 5 over h models this situation. We just talked about this problem in your, yellow region. So solve for h to the nearest 10,000th. Again, this does not say don't use your calculator. So you could always put one side in your calculator in y1, put the other in y2, and graph them. But let's do it algebraically for the sake of making sure we can. Base is 1/2, and it's to the 5 over h. So my exponential part is the base and the exponent. So let's start by getting that alone. So I'm going to divide both sides by 140. So that reduces to be 5/7. And you can make this 0.5, or you can leave it as 1/2. Now, once that's alone, we can convert to log. So this is going to be 5 over n equals log base 0.5 of 5 over 7. This is a number. So 5 over h equals, I'm not going to copy the whole thing out right now, but from my calculator, you should copy it all the way out. It's that. And now we can cross multiply, right? This is over 1, so cross multiply those. So 5 equals that number, which you would write all the way out, times h. Divide both sides by that, and so h is 10.30021 ... So 10.3002. That's the nearest 10,000th. All right, we've come to our final problem, ladies and gents. So last one, we'll do one more rational. Let's look at another LCD problem. So I see that this is a rational equation. I don't have answer choices to plug in, but never fear because LCD is here. So denominator of the first one, x. Denominator of the second one, 4. Denominator of the third one, 4x. Ooh, that's tricky. So let's do this. Let's copy our first denominator. Let's look at our second denominator and see if there's anything there that's missing. Ooh, yeah, there's no 4. Let's look at our third denominator and see if there's anything there that's missing. There is not. They're both there. So this is my LCD. Now, let's multiply that through. So 4x times each of these. Distribute that. So 4x over x minus 4x over 4 equals negative 4x over 4x. And a beautiful thing's about to happen. These cancel. Let's do some cancellations. 4. These cancel. X. These cancel. Negative 1 is left, right? So solving this, I get negative x equals negative 5. So x equals 5. Now check. Does that make this undefined? This would only be defined at x equals 0, right? X can't equal 0. That does check. So that's my solution. Okay, so that is our little crash course on all things solving. I'm going to hang out for 2 or 3 minutes, and if you have questions, you better send them now, because otherwise I need to go eat dinner. So send me questions. The whole answer key to this will be up on my teacher site after the actual paper copy. And obviously the video will be up there too. So questions, concerns? And you're just going to hear me clicking in the meantime because that's what I'm doing while I wait for you people. Because you're slow tonight. I am having tortilla soup, Mexican tortilla soup. I don't know. I made it. It's simmering. We'll see. It's pretty fancy. It's got like chicken. You put tortilla chips and avocado on top. Really exciting night in the G house. All right, guys. I'm going to call it. Nobody else has anything they want to ask. All right, guys. Have a wonderful evening, and I will see you all later.